Hi, this is a recording for the lesson on multiplying radical expressions. There are only 6 slides, including this introductory slide, so if you want to print it, it wouldn't take but 1 page. So the first thing we need to understand about multiplying radicals is the product rule. The product rule basically says that you can multiply anything under a radical. So if I have the square root of a times the square root of b, that would be equal to the square root of ab. Similarly, if I have 5 square root of 3 times 4 square root of 5, I can still multiply my radicands together. I can also multiply numbers outside of a radical together, or rather any number that's not under a radical. So to simplify this, 4 times 5 would give me 20, and 3 times 5 gives me 15. If I can further simplify, I should, but 15, the only factors are 5 and 3, besides 1 and 15, and that does not help me to simplify, so I'm done there. The example from the PowerPoint here says that the square root of 6 times the square root of 24 is equal to the square root of 144. Of course, if we get a perfect square, we simply want to have those memorized, so when we come across them, we'll know what the value is, and the square root of 144 is 12. Note, however, that a and b, meaning your radicands, must be real numbers to use this property for multiplying real numbers. If we were to end up with one that had an even root of a negative, it would be non-real, and therefore we would not be able to multiply. So if we try these, the first one we have here is square root of 2 times the square root of 8. Again, the product rule says all we have to do is multiply our radicands. So 2 times 8 is 16. And of course 16 is a perfect square, so our answer would simply be 4. Next, if we are having any other index other than squared, remember we are looking for 4 of the same factor. But pay attention, there's a little hint in here, because when we have the square root of, even root of a negative, we should know what to do. So don't forget that the even root of a negative number is not real. Remember, we'll learn in Math 3 how to simplify complex numbers, but for now it's not real. And we cannot multiply this number by this and get anything. So our answer is simply going to be not real because of the even root of a negative. So be careful and pay close attention to those. Next, we have the cube root of negative 5 times the cube root of 25. Remember, I told you that anytime you are taking an odd root of a negative number, to simply put the negative out front and change that to a positive. So when we multiply our radicands together, we have a negative out front, but we now have, and what you will see me do as we simplify is go ahead and break down our factors rather than do 5 times 25, which does give us 125. What I will do is, if knowing I'm going to have to break it down, I'll end up factoring it back out to 5 and 25. I simply write that under my radical. And I even get to where, instead of writing a 25, I'll write the factors out. So once you understand the process, you can streamline your work. So because we have an index of 3, we are looking for 3 of the same factor. I hope you also recognized that 125 is a perfect cube. So negative 5 is our answer. The cube root of negative 125 would be negative 5. And lastly here from the PowerPoint, we have the cube root of negative 16 times the cube root of 4. Recognize that we can take an odd root again of a negative, so I'm going to put that negative out front so you don't have to worry about any negative factors. And then when I multiply these, I'm going to go ahead and start breaking my factors down. So 16 I know is 4 times 4, but 4 and 4 continue to break down. So I know I'm going to have 2 2's to represent the factors of 4, another set of 2 2's to represent the factors of this 4, and then when I break down this 4, have 2 more. So 2 times 2 times 2 times 2 times 2 times 2 is the same thing as 16 times 4. But notice I'm streamlining my work if I know I have to break it down. So again, because my index is negative, or excuse me, my index is 3, I'm going to be forming groups of size 3. So, and mind you, this is 8. 2 times 2 times 2 is 8. The cube root of 8 is 2. So I have a 2 that comes out, and another 2 that comes out, and there's nothing left under my radical. So my answer is simply negative 4. So again, the process that we've been using the past few days still applies here. The only thing different is the product rule says we multiply the radicands and then we simplify. So this slide simply shows the stuff worked out if you were to print that out. So I've got 6 examples that I'm going to do with you, starting with E here. Alright, so for E, we have the cube root of 25x times the cube root of 125x to the 4th. So keep in mind, hopefully you've been picking up the last few days, I'm going to start using some shortcuts here. I know I'm going to end up breaking down the factors here as I multiply them. I just need to write them all under one radical. 25, the factors are 5 and 5. For 125, that's 5 times 25, but then 25 breaks down further into 2 more 5s. And of course I have x to the 4th, which leaves me with 4 x's. Again, because my index is 3, notice nothing's changed. I'm still doing the same simplifying we've been doing since the first lesson. I'm looking for 3 of the same factors. So I can group 3 5s, and I can also group 3 x's, but I do not have enough 5s to create another group of 3, and I don't have enough x's to create another group of 3. So a 5 comes out, an x comes out, we leave cube root. Make sure you show that very clearly that 3 is your index so it doesn't look like an exponent here of x, and we're going to multiply what's left. So we have the 5 and 5 and x, which when simplified, our final answer should look like 5x times the cube root of 25x squared. Remember, you can put this in your calculator to check. So if I want to check this, then I'm going to type in the cube root, and remember you go to math and then option 4, so the cube root of 25 times the cube root of 125. Remember, we can't put our variables in there. And then I'm going to go down here and put my answer in. So I'm going to type in 5 math 4 25. And because my decimal values come out to be the same, I know my answer here is correct, although I have to check over them with my x's. Next, for part F, we have the cube root of 27a to the 5th times the cube root of 4ab squared. And again, I'm going to make one long radical. This is 9 times 3, which breaks down to 3 3s and 5 a's. And then 4 breaks down to 2 and 2, an a and 2 b's. Looking for groups of size 3. And I do have these 2 that can join with this a. These cannot form groups of 3, so they remain under my radical. So I bring out a 3, 2 groups of a, and a 2, and a 2, and a b, and a b. So my final answer should look like 3a squared times the cube root of 4b squared. And of course, we can again verify that in our calculator. So next, we're going to look at using the distribution property to simplify. So this is why last weekend I had you all do homework to review how to multiply polynomials. So if we take a look at A, we're multiplying the square root of 5 times 4 plus 2 square roots of 5. So we're going to do this the same as we would multiply 5 times x minus 3, or plus 3. If we were to multiply that, 5 times x simply gives us 5x. We're going to put them together. And then 5 times 3 is 15. So the same process applies here. Only you need to remember that you can only multiply numbers under a radical together and numbers outside of a radical together. So in distributing the square root of 5 to 4, I'm going to have 4 square roots of 5. I'm not going to multiply them together. Plus, when I multiply this, I'm multiplying it by the whole term here. So my 2 doesn't have any other number other than 1 to be multiplied with, so it's just 2 square root of, and the square root of 5 times the square root of 5 is the square root of 25. And then we must simplify anything that can be simplified. Well, the square root of 25 we know is a perfect square. 25 is a perfect square, so that's going to be 2 times 5. At this point, all I can do is multiply these two integers. I cannot add these because they are not like terms. Recall from adding and subtracting integers that in order to add or subtract, you must have the same radical or radicand. So that would be my final answer. For part B, we have 4 square root of 7 times 5a minus 5 square root of ab. So all the rules still apply. Because when I multiply this term times 5a, I have 4 outside of a radical and I have 5 that's not in a radical. I can multiply the 4 and the 5 together. So 4 times 5 gives me 20. I also have the a not in a radical, and I have the square root of 7. There's no other radical to multiply it with, so I simply bring that down. Now I'm going to distribute the 4 square root of 7 to the next term, bringing down my minus. The 4 and the 5 can be multiplied because they're both outside of a radical. The 7 can be multiplied with the AB and stays under the radical. Because I do not have like terms, while they have 7 under the radical, I do not have an AB here for my first term. So I have done everything I can do to simplify. I'm all done. For part C, this is where we are now going to employ the double distribution method, or FOIL, or box method if you prefer, although I'd really like you to try to get away from using that method. Make sure you can see that minus. We are going to first distribute the 3 to both terms. So 3 times 4 is 12. 3 times a negative square root of 3 is negative 3 square roots of 3. Notice I'm not multiplying the 3 and 3 because 3 is not in a radical, but this 3 is. Then I'm going to distribute my second term in my first binomial. When I multiply 6 square root of 5 times 4, I'm allowed to multiply the 6 and the 4 because they are not in radicals. So 6 times 4 is 20 square roots of 5 minus, and then when I distribute my last, 6 times a negative 1 will just give me minus 6 square root of 15. Now again, when I'm done distributing, if I am able to simplify anything under the radical, I need to do so. But because I can't, I am done. And next I'll flip the page so you can get D. Remember, at any time you can pause this video to write this stuff down. So last one for multiplying. Let's see, 2 minus 7 square root of 2 times the quantity 5 minus the square root of 2. Again, I'm going to employ the same process. So 2 times 5 is 10. 2 times negative square root of 2 is negative 2 square roots of 2. Remember, one's not in a radical, that one is in a radical. Now I can distribute these two terms. So negative 7 times 5 is negative 35 square roots of 2. There's nothing, no radical to multiply my square root of 2 with. So I just write it down. and then distribute my last terms, and negative 7 times a negative understood 1 is a positive 7 square root of 4, because I can multiply the 2 and the 2 under the radical. But I should, of course, simplify anything under here. So when I see a perfect square or a radical that can be broken down and simplified, I will do so. So the square root of 4 is 2. I multiply that 2 by the 7 out front. 7 times 2 is 14. At this point, I recognize that I have an integer 10 here and 14, both positive. I need to combine like terms at this time. So 10 and 14 is 24. And these two terms also are like terms because they have the square root of 2. Negative 2 minus 35 is negative 37 square roots of 2. I do not have any like terms, so I am through. And that concludes your lesson on multiplying radicals.